and everyone. Myself, Mr. Gulakhe Bhau Ashok, रयत शिक्षण संस्थाज आबासाहेब मराठे आर्ट्स and New Commerce Science College, Rajapur District, Ratnagiri. Today's lectures we have see the topics mechanism of organic reaction. In this topic, the last times we have seen the various types of arrows which are used in organic reaction mechanism. This type of arrow which shows having the different applications. Now we have seen the same topics like intermediates. In two-step reaction, the reactants are first converted into an intermediate through a transition state. In second step, the intermediate change into products through another transition state. See as firstly, these reactants are converted to first transition state, and this transition state is converted into intermediate. And these intermediates are converted to second transition state, and then this second transition state convert to the products. So we have see how will you convert this reactant to products. Some types of interconversions are there. Why it is observed? Because the intermediate is a short-lived, charged or uncharged species having a definite molecular structure and shape. We have seen these examples like tertiary butyl bromide. We have take in reaction. What happens? First step is a partially ionization of CBr bond. After ionization of the CBr bond, breaking this bond and to get tertiary butyl carbocation. These tertiary butyl carbocation which are more stable. This is a first transition state. Then after what happens? This tertiary butyl carbocation, the nucleophile OH minus is attacked and to get the partially formed COH bond. This is a second transition state. And then after completely form COH bond to get the product as tertiary butyl alcohol. So this tertiary butyl bromide to tertiary butyl alcohol are take place through two types of transition state. This is the first transition state. This is a second transition state. Now we have see the difference between transition state and intermediate. But you know that intermediate has the slightly less energy than transition state due to relative more stable than transition state. Intermediate can exist for a longer time than transition state. In some cases, intermediate can be isolated under special conditions. But you know that the relative energies of all species in reaction can be understood by energy profile diagram. The difference in energy of transition state and reactants is called as energy of activation. If energy of activation is less, then reaction is takes place more favored. Now we have to see the detailed difference between the transition state and intermediate. The first point, in transition state, what happens? It is not a definite molecular species. Means that it is not definite species, but intermediate has definite molecular species. Second point, it is a given an imaginary structure means that it is not correct geometry of the structure are shown by transition state, but intermediate has a definite structure and their shape. In transition state, third point, it is highest energy and least stability. But opposite to intermediate, it is slightly less energy and more stable than transition state. There is no proof for existence, but intermediate, it is existence and can be detected by the chemical technique method. Next point, it cannot be isolated of transition state, but intermediate it can be isolated under special conditions. Transition state form in all reactions, but intermediate cannot be formed in multi-step reaction. So these some points we have seen the difference between state and inter. Now, next point we are going to nucleophilicity and basicity. Nucleophile is an species having the unshared electron pair which can utilize to react with electron deficient species. Another definition of nucleophile are the nucleophiles are electron-rich species. For example, OH minus, SH minus, OR minus, Cn minus, RCOO minus, ROH, NH3, RNH2, etc. This is some examples of the nucleophiles. All nucleophiles are Lewis bases. This is very important point to show. The nucleophiles are Lewis bases. We have seen the relative strength of the base, which is expressed in terms of the basicity. Basicity, which are measured in terms of Kb or pKb. The smaller the value of pKb means it is a stronger base. For example, the ammonia has 4.7 which is stronger base than pyridine it having 8.8. Basicity is indicates the extent to which the base accept the proton. It is a thermodynamic term which affect the position of acid-base equilibrium. If the basicity is more, then acid-base equilibrium will be more towards right hand side. Now, next point we have see the nucleophilicity. You know that nucleophiles, electron rich species are called as nucleophiles. So nucleophilicity are the different terms means that the strength nucleophilicity is the measure of the strength of the nucleophile, which indicate the relative reactivity of different nucleophiles. Hence, I define nucleophilicity is the measure of how fast a Lewis base forms a bond with suitable substrate and displace the leaving group. This is called as the nucleophilicity. You know that nucleophilicity? Nucleophilicity means to measure the strength of the nucleophiles. So measure the strength of the nucleophile, which is fast Lewis base form the bond with suitable substrate and displace the leaving group. R shows the nucleophilicity. Nucleophilicity it is a kinetic term and nucleophiles it is also a thermodynamic term. Sorry, basicity. Basicity it is a thermodynamic term. Nucleophilicity it is a kinetic term. It affects the rate of reaction. Hence, it is a higher the nucleophilicity, higher will be its rate of reaction will be rate of reaction with electrophile with lower activation energy. Nucleophilicity is a relative term, means it has absolute value. We determine by measuring the rate at which the different nucleophiles react with substrate with methyl halide relative to standard nucleophiles like methanol. We have compared these two. It is alcohol and this is ions of the alcohol. Both having which is a better nucleophiles. This is a better nucleophile than alcohol. Anions have a higher nucleophilicity and are better nucleophile than a neutral molecules. If the two molecules having a same nucleophilic atom here, it is also nucleophilic atom as oxygen. It is also nucleophilic atom as oxygen. Then nucleophilicity increases with increasing basicity. So which is stronger base and which is a weaker base we have compared according to the this negative charge which is stabilized. We have see these negative charge which are destabilized but negative charge on the oxygen which is stabilized along this carbonyl carbon and therefore it is a weak base and it is a strong base and therefore the nucleophilicity of that atom will be more than this. In periodic table, we have C from top to bottom. The basicity decreases and nucleophilicity will be increases. For example, we have take this iodide, which is less basic but better nucleophile than fluoride. Due to these ions will be solvated by water more than this iodide. Hence, it is a weaker nucleophile 9I minus, which is same reason as the OH minus, more basic but less nucleophile than SH minus. Next point, we have going to difference between the basicity and nucleophilicity. The first difference we have, see, what is the basicity? Basicity are which accept the base, sorry, tend to which base accept the proton as a basicity. Nucleophilicity, it is the rate which the nucleophile forms the bond with substrate. This is called nucleophilicity. It is a absolute value, means that it measured in terms of kb or pkb. Nucleophilicity, it is a relative term. Basicity, it is a thermodynamic term, and nucleophilicity, it is a kinetic term. Means that which measure the rate of reaction. Basicity, which affect the position of acid-base equilibrium, and nucleophilicity, which affect the rate of reaction. For example, OH minus is a good base and SH minus is a good nucleophile, because the size of atom will be more, it is a good nucleophile. We have seen in detail basicity and the nucleophilicity. Now we are going to the electrophilicity and acidity. You know that nucleophiles are electron-rich species and which attack the electron-deficient species. Similarly, electrophile are electron-deficient species and which accept the electron pair to form the bond with substrate are called as electrophile. Or another definition, electron-loving species are called as electrophile. For example, the H plus, NO plus, NO2 plus, Cl plus, Br plus, R plus, AlCl3 as a Lewis acid, FeCl3, it is also Lewis acid, SO3, SnCl4. All Lewis acids are electrophile. But good acids may not be good electrophiles. We know that acidity is the extent to which the species loses the protons, and it measured in terms of Ka or pKb. Acidity, it is a thermodynamic term. It indicates the position of equilibrium in acid-base reactions. Means that acidity is higher, then position of equilibrium will be more to the right hand side. Electrophilicity is the rate at which the acid accepts the electrons and forms bond with substrate. Similarly, we have seen the nucleophilicity is the rate at which the attack of nucleophiles. Strength of the nucleophile are called as nucleophilicity, Similarly, the electrophilicity is the rate at which the acid accepts the electrons and forms the bonds with substrate. Electrophilicity, it is a kinetic term which measures the rate of reaction. Electrophilicity is more than it reacts faster with lower activation energy. Now we have see the charge species. See here, charge species are more electrophilic than the neutral molecules. For example, we have see this. This is a charged species that is a Br plus, which is more electrophilic than Br2 as a neutral molecules. Similarly, R plus molecules, it is a greater electrophile than this alkyl chloride as a neutral molecule. Next point, the alkyl halides are weakly electrophilic when Lewis acid is added to the electrophilicity is increases. For example, we have this, see this example methyl chloride. These methyl chloride are less electrophilic, but when we have add this Lewis acid, the electrophilicity will be increased. Like this electrophilicity, it will be increased and breaking of this R and halide bond is greatly and to form R plus as a carbocation. In another examples, in carbonyl carbon is electrophilic. See here this carbonyl carbon. This carbon is electrophilic because the bond is a polar. Electrophilicity can be increased by addition of protic acid. Like we have add this protic acid H plus to get protonate of this oxygen and to form positive charge on this. Therefore, electrophilicity will be increased by carbonyl carbon. So this is more electrophilic. This is a less electrophilic. Now let's we have see the difference between the acidity and electrophilicity. The first point, it is extent to which the acid donate the proton or accept the electrons are named as a acidity. Electrophilicity, it is the rate at which electrophiles form the bond with substrate. This is called as electrophilicity. The second point, it is the absolute value which is measured in terms of Ka or pKa, and electrophilicity is relative term. Acidity, it is a thermodynamic term, and electrophilicity is kinetic term. Acidity, which affects the position of acid-base equilibrium, and electrophilicity, which affect the rate of reaction. For example, the HCl, HBr, and electrophilicity like NO2 plus, R plus.